Okay, so good day everyone. So today's class will essentially be doing a little bit of dictionaries and obviously we'll have functions and all those things again. And I do once again, just like last week, if you want to solve your own questions, you can solve the questions up here, and that should will it kind of go through some of the questions if you have any methods how to solve it and things like that. But firstly, I think it's quite important to first go through what dictionaries are and things like that. So before that, are there any questions regarding last week or last week's lectures and things like that? If there are, feel free to ask because I kind of want the class to be interactive. Okay, so if there are no questions, we'll just go through some things. So before we look into what dictionaries are, oh, okay, essentially I hope we are all on the same page and we know what dictionaries are. So we define a dictionary using uh, curly brackets, and that means it's a dictionary. So if it's a dictionary, I can store values, I can retrieve values, and I can try to retrieve values that are not there. So you can kind of guess what the output of this function would be. So if I run the code, yeah, the first value is properly printed as 1000 because that is what the first thing is. But the second value, I have not stored a second value into it, so it won't print it. But what are the things which can go inside this? Is it just strings? I mean, we can put numbers and that will work. So as I've printed the value of a dictionary, we can see that this is how it's stored in a dictionary. So what if I do this? Will this give a key error or something like that, or will it just work out fine? So what do you think? Did someone raise their hand? Oh, okay, I don't see anything. Okay, we'll run and see. So when you run, this is the output you get. Essentially, somehow it has stored this as also. So how about instead of this, we can store a list also. Now that will be fun. A of 3 comma 4 because I'm essentially making a list of 3 comma 4 and putting it inside. But this gives me an error. So kind of there are only certain values you're allowed to put inside a dictionary. We can understand that by looking at the error here. The error here is it's a type error. We have an unhashable type. What does that mean? So I guess you do not know what unhashable means, or is there anyone in the chat who knows? Okay, in short, a dictionary is a very large array, and instead of, so when I say something's a dictionary, Python immediately gives it like a lot of space. It gives it like a lot of space, okay? And then when I say a of first value is equal to 1000, Python will take this first value and take the hash of the first value. A hash is a function which takes an input and just gives you another output. You generally a number and which is much smaller. So we can we can see how that works like this. Pretty sure hash is a number, yeah. For the print. So here, if I hash first value, I get this weird number. Similarly, every number has most of the numbers here have a hash. So I can also take a hash of a tuple. Two comma 3. And if I hash a tuple, I get this number, which is clearly different from this. The idea behind a hash is two things should hopefully not have the same hash. Okay? So, I told you earlier that when I say a is equal to dictionary, what Python does is it allocates a huge chunk of array with nothing, okay? And then when I say a of first value, it takes a hash of the first value and goes to that location. And it converts that location to 1000. And it goes to a of 3, it goes to that location and it takes a hash of 3. I should have Python open. Give me a second. So I can take hash of 3. Okay, so things like this can happen. So hash of 3 happens to be 3. So it'll go to the location 3 and put that value. 2626622. But that means certain things can have the same hash value. For example, the hash of 1 is 1. The hash of the boolean true is also 1. So if I do a of 1 is equal to 1000, and then I do a of true is equal to 3000, print a of 1 will print 3000. I don't need this. Did that make sense? I hope that made sense. Okay, so moving on. So essentially, the thing inside the key of the dictionary has to be something which can be hashed. Most in general, if something is like a tuple or a fixed string like first strings or numbers or floats, of 1.0, that's also 1. So you can see, like, even these two numbers are very similar, the hash will be completely different. Anyway, my point is, As long as something can be hashed, you can put it inside, you can make it use that thing as a key for a dictionary. On the other hand, if you cannot hash it, it will give you the error which I showed you earlier, an unhashable type. Note that this is only for the first value. So I can put an unhashable thing here. So I can do a of 23 is equal to 1, 2, 3, 4. We have agreed that array is a list is not hashable, but this still works. Print a. Yeah, so it has values exactly as how we expected. The first value is 1000, 3 is 262, 23, which is the one I have written here, will have this value. I hope that made sense. Wait, give me a. So I hope that part made sense. So where can you use a dictionary? A dictionary can as it's like super useful for computer programming and all, but okay, it's super useful for computer program for things like this. For this question, like calculate the 50th Fibonacci number. It's not a difficult question, but let's just quickly go through it. So if you remember the recursive function, we did this. Say bo n if n is greater than less than or equal to 1. So I hope you all remember how the Fibonacci function worked, and we did this last class essentially. So I hope this is not too foreign. So here, so this function prints the first 10 numbers of Fibonacci sequence. Let's make it 20. Yeah, it ran pretty fine. Okay, let's make it like 30. That worked great. But now, if I run this for 40, look at what happens. The program has stopped. It's not printed any values. So essentially, this is what people mean when they say Python is slow. Python was trying to calculate these numbers, but because of my highly inefficient code, I'll explain why this is inefficient in some time. Because of my highly inefficient code, this took a lot of time. And if I had to do this for 50, as my question says, it'll take a significantly more time. Okay. So, do you know why this is such a slow program? Okay, so the main reason this is slow is because of how many times it has to calculate things it has already calculated. For example, say I will change this function slightly to make it to show the steps it's taking a little better. Print. Yeah, this is using recursion because the Fibonacci sequence is defined recursively, right? So wait, give me a second. I just put, yeah, like the definition of the Fibonacci number was sum of the next Fibonacci number is the sum of the previous two. So that is, if I have to calculate Fibonacci of n, I must calculate Fibonacci of n minus 1 and n minus 2. Okay, so let's just see this, see what it's doing for like till we'll just Fib of 5. So right now I'm just calculating the Fibonacci number of 5. Okay, I mean the fifth Fibonacci number. To calculate the fifth Fibonacci number, it does all these calculations. It first wants to calculate 5, so it calculates 4 first, then it calculates 3, 2, 1, 0, and then it calculates 1 and 2 again, and calculates 1 again, and 3 again, and there's a lot of repetition. The easier way to see this is, why not just draw paint? So, to calculate Fibonacci of To calculate Fibonacci of 5, it has to calculate Fibonacci of 4 and Fibonacci of 3. To calculate Fibonacci of 4, well, it has to calculate Fibonacci of 3 and Fibonacci of 2. And this keeps going. To calculate Fibonacci of 3, you need 2 and 1. To calculate Fibonacci of 2, you need 1 and 0. So to calculate, and the worst part is it has to keep doing it. So this to calculate Fibonacci of 2, once again it needs to calculate 1 and 0 again. Three is 2 and 1, and again there's another 1 and 0. So it essentially has to add this up. It has to calculate this once. There's an addition here, there's an addition here. There's like 1, 2, 3, 4, 5, 6, 7. There's 7 additions for this, out of which many of these additions are repeated. Like this, where did the so this, oh god, this is the same thing as this, which is the same thing as this. So you're having repeated calculations in many places. In fact, like this is the same thing as this. So if I found a way to just save the previous values, I will have to do a lot less recursion, a lot less repeated addition. So one way people do this is using a dictionary. So I'll set dictionary, no, Fibonacci numbers is equal. Now, before I calculate it, I check if I have already calculated it. So this dictionary is supposed to have all the calculated Fibonacci numbers. So I first check that. If n in Fibonacci numbers, if it is, then we can return that directly. Sorry. Otherwise, we have to calculate it. So we'll just number is equal to, and once I've calculated it, I'll store it here. Fibonacci number of n is equal to number, and now I'll return the number. Okay. I will keep the print statement to show you how much less calculations I have to do this time. And this time it just does 5 calculations. Okay, so it does 5 because technically we can include 0 here. Okay. Yeah, it does far fewer calculations this time. So now if I want to calculate Fibonacci of 50, yeah, it will take some time, but it took a lot less time than calculating for 40, right? So essentially the main reason is when it calculated Fibonacci of n minus 1, it had already calculated the Fibonacci of n minus 2. So it didn't have to repeat the calculations. So this is something, I hope the steps made sense. This is called memoization. Give me a second. This is called memoization. That is, when you have certain code which does the same calculation again and again, it makes sense for you to store the values in some dictionary or array. And that's what this thing is. In fact, many questions in the coding assignment I had given last week, the lead code, in lead code, you cannot solve many of them without memoization. Sorry. Anyways, so I hope that showed you how to do the Fibonacci thing. So can you try the second question? Can you try the second question while I finish coughing? So do any of you have any idea how to solve the second question? So if you want more of this thing, so say I have a dictionary 1, so I have to create these two will give me some C, which is so do you have any idea? Okay, so I should have explained this a little earlier. Python, in dictionaries in Python are also iterables. So you can do for element in A and print A. Sorry. But what do you think this will print? So big that won't work, but I can show you it won't work. Does it work? Yeah, okay, thank goodness. Okay, so you can't add two dictionaries because that doesn't make sense, right? So you have to think a little to get it to work. While you're solving that, what do you think this will print? So did you expect that? Essentially, if you want to go through the values you have given to the dictionary, you can do for key in the dictionary. And given the key, you can also find the value, right? So if you can do f key is key, value is a of key. Does that make sense? So if you have a dictionary, you can iterate over the dictionaries and have most of the things you want in a, like the same way you work with lists and tuples, you can kind of work with dictionaries. So you can use the the for loop is incredibly useful here also. So this is one hint I can give you for the question 2 I've given. Okay, so the easy solution would be, so we first start with the new empty dictionary, and we put that dictionary into this. Likewise, we do it for B also. So did that make sense? There's a small issue with the code I have right now. Do you guys see it? And honestly, that issue is there with the fundamental question. So what if both the dictionaries had value the same key? So will C have 4 or 2? Because, well, if I'm merging these two dictionaries, I should merge them, right? So I can't just throw away information. So yeah, technically the question is ill posed. It depends if the same list is the same value is there into this thing. So, but in that case, we can still work with it. One logical thing to do is to make a list now. So instead of doing this, I'll first check if the key is inside the thing already. So if E and C, then C of key is a tuple of the old one and new one. So that can also work. So right now, if I give 23 and a value of so 23 right now is a tuple with the value of both the first list and the second list, which kind of makes sense in my opinion. Okay, so I should highlight this. Okay. Anyway, so I guess the next thing which I really would recommend is it is in addition to the normal Python stuff we have been doing, there's a nicer way to code in Python using something called interactive Python notebooks. So you might have heard of this, and there are like multiple ways you can go about it. But if you have Anaconda and the default version of Anaconda, then you should have something called Jupyter notebooks. So if I search, you can see I have something called a Jupyter notebook. If you don't, it's okay. There you can Google how to install it. It's not too difficult. But if you want me to see how check out your installation, I can do that for you. So I have already opened it. So when you open a Jupyter notebook, it usually opens it in some browser. So it will look like this. Okay, actually it will look like this. And when you make a file in Jupyter notebooks, it will look like this. So the name of the file is here, and all information about the file is in different places. And this is essentially just a normal Python environment. So I can do and you can run it, and that's exactly what you get. It's almost the same thing of the of Spider or VS Code, but it's nicer in my opinion, right? Like you can see why this is slightly more convenient than, well, the VS Code or Spider. You can also define functions. Def and it calculated. And thing is, and the thing is, whatever you've done so far will be saved, and you don't have to keep running the same file again and again. Like right now, if I have to calculate Fibo of 51, it won't do all the calculating steps again. Okay, it'll do just one. So if I run this, it'll just calculate the Fibonacci of 51 and it'll print it. So this is a quick look into what Python notebooks are. There are lots of additional things you can do, like change the themes and stuff like that. You can also do, you can also have import statements. Import numpy as np, np.a. Oh, so instead of clicking run here, you can do shift enter and it will run the same file. I mean, the same cell. In addition to this, there are also Python notebooks in Google. So if you have a Google account, if you open your Google Drive, you can do something called Google Colab. Oh, what happened in the second week? Yeah, it's called Google Collaboratory. And if you open that, it looks slightly slow to begin with, but otherwise it's actually quite. And because I do everything in dark theme, this all automatically opened in the dark theme. So we can do essentially the same thing. So if you don't have Python installed in your computer, you can always do it in online. There are only small caveats using Google Collaboratory online, because if you use this too much, then it will stop you. Like, for example, like running a code for like 4 days is not allowed. So like if you try to keep running one code for like 4 days, Google Colab will be like, you have exceeded your time, but you have exceeded the amount of Google Colab you can do in 1 week. So you'll have to do it again like next week or something like that. But that things like that are only an issue if you're doing like changing the runtime to GPUs and things like that. So that's a quick introduction to Jupyter notebooks, interactive Python notebooks. So, however, even though Jupyter notebooks are cool and all, and Python or Google Colabs are nice and all, in the end, the best place to do all of those is still in VS Code, to be in my opinion, because you can open Python notebooks in VS Code, and the format here is just better. Right? It has all of the things you would need, and like once again, the autocomplete is better here. Where did it go? Yeah, the autocomplete is just better. Like the autocomplete in VS Code is just faster. So there's almost no reason I'll use the actual Jupyter notebooks. So one thing that can confuse you is the file type is now different. Earlier it's a .py, remember, because it's a Python file. But this time it's a .ipynb, which is a mouthful, but it's easy if you remember. It stands for Interactive Python Notebook. So IPY Notebook NB. So from now on, the rest of the classes, I will probably solving the questions in the Interactive Python Notebook instead. And I would recommend, like, if you are following along to try like this and so on. So figure of 23. Give me a second. Yeah. So there are other reasons why I really prefer interactive Python notebooks. So one thing you can see about all the code is that it's just all code. However, with Python notebooks, you can include things which are not code. You can comment your code slightly better. So I can write things in like normal text. And this is using a syntax called Markdown, which is like quite famous online. So if you want, you can look into it. It also has like very basic maths. So the moment I click out, if I click this checkbox, it will format it correctly. So you can see how there are advantages using interactive Python notebooks, and it's actually significantly more powerful than this also. For example, there's a really cool Python package called SymPy. Sure, it's SymPy. Oh, it's symbol. It's okay. So now you can do like proper maths with this. X square plus y square. It will properly print it as x square plus y square. So
Voice.
could you repeat? I didn't get you. Someone had a question? So another thing you would have noticed is I
Voice not coming, sir.
voice is not coming.
You're not audible.
Uh, my voice is not coming, but hello. It's
Yes, sir.
you can hear me, right?
Yes, sir.
Okay. So was I always audible or was I inaudible for some time?
Sir, inaudible for some time.
Okay. That's probably what had happened. Okay, anyway. So Nikunj, I hope I'm audible now.
Yes, sir. Yes, sir.
Okay.
Now.
Okay. So another thing you can notice about the interactive Python notebooks is that I didn't print this. I didn't do print of x square plus y squared. Essentially, interactive Python notebooks knows how to format certain outputs. So I don't have to write print Fibonacci of 20. I can just write Fibo of 20 and it will give me the value. So there are just like lots of major and minor conveniences with interactive Python notebooks, which will just make it much easier for you to code in. So, like, there are lots of keyboard shortcuts available. Like, you can also look at all the values of variables and things like that. Oh god, my throat. Okay, anyways. So, is there any questions regarding this? Okay, so the next thing I will do is like talk a little bit about Python sets. So sometimes you just want, so we'll go through the mathematical definition of a set first. So in maths, like this is a set. A set is essentially just a collection of items. Now, according to the mathematical definition of a set, you cannot have the same thing repeat within a set. So if I cannot 1 comma 4 comma 1 is the same thing as 1 comma 4 because a set the 1 is the repeated and that's not allowed, or rather it's repeated so it's not counted. So similarly, Python also has a set, but unfortunately, unlike dictionaries and tuples, it's you have to specifically write it out. So I have to write q is equal to set. Okay, and you have all the you can look at the autocomplete and look at the definition things you can add and things like that. So many of these are the normal mathematical definitions. So if I have two sets, so I'll just add a couple of things. So 1 comma 2 comma, so if you look at this set, I've given it the values 1 2 4 6 2 and 1, and but 2 and 1 are not repeated, so q just has this. Now I can make another one. W is equal to set of 2 4 11 16 3 and 1. No need for 1 again. So I can now do and you can see how this gives you the mathematical definition of a difference of two sets. So I've taken the set W and removed every element that's in Q, which happens to be 2 and 4 this time. So I hope that made sense. Okay, unfortunately, I think I will end today's class in like 10 minutes because my throat is not working. If you have any questions, feel free to ask. I will stay online till 8 o'clock, but you can leave before that if you. I will stop explaining concepts at 7. My throat is not working out today, so I'm very sorry for that. So meanwhile, can someone try to do the fourth question? This question, that is.
Sir, can you show the fourth question?
Uh,
Sir?
Wait. I can just move this up. Give me a second.
Yes, sir. I take it. Yes.
I will
Thank
try
you.
my best to get well. Is that better? Wait, I don't need these questions anymore, so that's better. Oof. I hope that's fine. Yeah. If any of you are trying, the third question is more difficult than you expect it to be. So, I mean, especially with the extras. A small uh, spoiler for the fourth question: you do not need set or dictionaries to the fourth question, but the concept of set might be useful in one of the assignments. So, do any of you have any idea how to do the fourth question? I hope the fourth question is clear. Okay, so let's start with the fourth question. So, first, let's find all possible 6-digit numbers like 5555, 666, and so on. So, that is not too difficult to do. The easiest way I can think of is to use the range. So essentially, output of this function is all numbers like 111, 111, 222, 222, and so on. So since all the numbers clearly have a pattern to them, so we'll just quickly do that. And pretty sure this is just range of 10. So range of 10 gives you numbers from, okay, so I'll start with 1. Yeah, range of 10 will give you range of 1 comma 10 will give you numbers 1 to 9. So for I in range of 10, I'll have to make a list to show the values. So numbers is equal to this thing. Now I will do something which is very hacky because it's far more fun to do things that way. So new number is equal to, I'll convert I into a string. Now I'll convert the string now. Because it's a string, I can multiply it with a number. So I'll multiply this with a 6 with 6. Now the first number will be 1. After I convert to a string, it will be the string 1. If I multiply the string 1 with 6, I'll get 111 111, and I can convert this back into an integer. And that's what I wanted. So numbers dot append return numbers. So I'll call the function and let's see. And yes, that's exactly what I wanted. I hope this made sense. I agree, this is a very hacky solution. You can think of more logical ways to do this. In fact, the most easy way. Yeah, sometimes you write a solution and you just immediately realize it's a much easier solution. And in this case, it'll just be, I can just multiply this with the number I. I confess that I thought of this solution because of this can you solve for any digit pre-requirement, because I knew I was going to solve this for any digit, and this way I can easily extend this to any solution. So I can give it a number n there and multiply it here. So to get so so now if I wanted to solve this for 9 digits, I could just change that and I would get the answer. Anyway, so now we have the list of numbers. Now let's try. So we want to make sure we have the largest number which has that property, right? So we'll just call that number m. So we'll just call that 0 for now. I need to divide these numbers from 1 to 9 and check if that number is a 5-digit number. So let's try that. So for number in generate 6, so this number will be numbers like this. I'll first, for number in range 1 to 10, oh, digit, if number mod digit is equal to 0, so only in the case that the number is divisible by the digit, I need to care more about it, right? So I'll also have to check if the thing has 5 digits. After I divide it by, after I divide, I need to make sure it has one less digit, right? So once again, to check, I might as well make this a function because functions are cool. Check num digit and the easiest way to do this is you can see it's a hack, but it works. So num digit of number divided by digit is not equal to 5, I continue. scaring people off, but that's okay. I hope I don't scare too many people. Okay, start equal to 5, I continue. And then now I'll check if divided is greater than the value I've already found. Divided is greater than m, then m is equal to divided. That's it. So we can run this and it should work. I forgot to store the value, obviously. Oh no. Okay, we should add an int here. Okay, good. The mistake I had made earlier was, if I just do normal division, it will think of it as a floating point number, which makes sense because most of the time division gives you a floating point number. So when I did then found the number of digits of the divided, it has to be strictly 5, right? But a floating point number will have extra digits at the end. So that's why it was wrong earlier. But now it's fine because apparently when you run this, the value we get is this. So if I take m multiplied by for I in range 10, yeah. So that means if apparently this number multiplied by 6 will give you 6, no, this number multiplied by 7 will give you 666, and therefore this is the biggest number. And you can kind of see how this can easily be generated to any digit. So my digit is equal to 10. So for 10 digit, oh god, oh yeah, oh. Oh, okay. So I thought I was wrong, but apparently, if you have 10 digits, it's just not possible, which kind of makes sense. You need 9 digits. Yeah, if you have 9 digits, the largest number will be this. So if you have 10 digits, apparently you'll never find a you won't you will never find the largest 9-digit number that when multiplied by a 1-digit number gives you a 6-digit number like this. But Apparently, you can do it for 9. Sorry, I had a small. I didn't think properly there. So so the largest 9-digit number which does this will be so and so. So there you go. If you have any questions, feel free to ask. I will quietly sit here for the rest of the class.
शो करावे है